natural dyes from plants sourced for biological staining. Coming to the introduction part. Natural dyes, these are the dyes or they are the colorants that are derived from the natural plants. Color of any substance is not necessarily a dye. To say that it is a dye, it should fix to fabrics permanently. That is, they should neither fade on exposure to light nor wash out with soap. All parts of the plant can be used as a dye, that is leaves, fruits, bark, seed, roots, rhizome, flower. And natural dyes, they are used in coloring textiles. Also, they are used in coloring foodstuffs. They are used in cosmetics also to prepare various drugs. Review of literature. Guyan and Saikia in 2004, they isolated colored compounds of 5 different plants in northeastern India, and they also did some spectroscopic analysis of those. Then Josna Desai in 2008, she studied about 20 natural dyes, and she also used some mordants. Mordants are the chemicals which enhance the staining property of the dyes. Then Obenava Kolonji in 2010, he extracted about 30 dyes and he studied the effect of those dyes as a colorants for food and textiles. Puna Jan and al. In 2011, he isolated a natural dye from the Lawsonia inermis, that is Lawson. He extracted it in 3 different solvents, that is ethyl alcohol, clove oil and water, and tested its effectiveness on the effectiveness as a staining agent for the angiospermic stem tissue. Sharma and Prima et al. In 2012, he reported about 46 dyes in plants in Kharwal district of Himalaya, India. Now my 3 objectives were to identify the natural dye in the plants and to extract the dye from them, to study the staining property of them on various plant sections, and to carry out the spectral analysis and to detect the chromophores which are present here. So materials and method. I selected 12 different plant species which belong to 11 different families. 2 species were collected from the Goa University campus, that is Cassia fistula and Telpis erecta. From Trolle College campus, 1 species was collected, that is Victoria talacea. From Ambedkar garden of Pontifixa Orellana, and most of the species were collected from the Marga media. There is genus and species of noted down, and the part in which the dye was used for further study. Then this is the part of the plant which I have used, and these are the examples. These are the examples. So I took 1 gram of sample and dissolved it in 10 ml of distilled water. I have prepared 2 solvents. In distilled water also I have dissolved, and I have also dissolved in it with ethanol. So then sectioning and staining, 4 different sections was taken: dipod strand, dipod seed, monopod strand and monopod seed. For dipod strands, either Chromotina orbita or Lantana camera was used. For dipod seed, Phaseolus aureus was used. For monopod strand, Cyanodon dactylon, and for monopod seed, Oryza sativa was used. And later the extracted dye was tested on these particular sections for about 10 to 15 minutes, and later it was photographed under Nikon's microscope. Then even the chemical analysis of extracted dye was done using the UV spectrophotometer. Here the raw sample was weighed first, that is 0.01 gram, and I dissolved it in 6 ml of water. And I also dissolved it in methanol, and later I filtered it using the muslin cloth. And some extracts were also filtered using the Whatman filter paper in order to get a clear solution. And then methanol was used as blend for methanol dissolved samples, and water was used as blend for water dissolved samples. And later the samples were run on the spectrophotometer at a wavelength of about 720 to 400 nanometer. Also 4 synthetic dye spectra are put. In which 0.001 gram was weighed, and it was dissolved in 6 ml of methanol, and it was run on 700 to 400 nanometer UV spectrum. Coming to the results and discussion. So 12 dyes are extracted from 11 different families. So these are my dyes which I have extracted, and this is the common name family, the part which I have used, the color, what color it is, and some uses of it. So Indian Sepa, it is used for coloring natural textile materials. Vixa Orellana has all of your know, it is used in making lipsticks, and also it is used in coloring some food stuff. Kurkuma longa, the dye which is the yellow color dye which is aided from the rhizome of Kurkuma longa, it is used as an antiseptic. Then Lawsonia inermis, the brown red color dye which is aided from the leaves of Lawsonia inermis, it is used in as mehndi and also for preparing some hair dyeing products. So this paper shows you the color difference between the dye extracted in water and methanol. Here ATM Sepa showed color only in water, it did not give any color in the methanol. Whereas Areca Catechol gave color in both, that is light pinkish color was also. Pixa Orellano gave color only in the methanol, here you can see the dark yellow color, whereas it did not give any color in the water. Then Cassia, Clitoria and Curcuma, they gave color in both water as well as in methanol. Garcinia and Indica and Nicantis arboristiis, they gave color in both water and methanol. And Lawsonia it gave color only in water, it did not give color in the methanol. And for Nicantis arboristiis, I have used the part of the flower that is corolla tube of the flower. Then Pubica, Tagetes and Tectona, they get color in both water as well as methanol. This paper shows the effect of natural dyes on the biological staining. So these are the 4 different sections I have taken, and this shows you the effect of particular dye which is extracted in water in this particular sections. So here the cuticle and epidermis was dark brown in color, pith was light brown, and xylem and phloem was light brown. This you can see further in my sections. Then cotyledonous cells were light brown. Then in Cassia fistula, cuticle epidermis was stained dark brown, pith was stained light brown, xylem, phloem was stained brown. So these all the things which I have highlighted in red, it indicates that this particular sections is well stained in those particular dyes. And this paper shows the staining property of various dyes which are extracted in methanol. So in the methanol, Pixa Orellano gave better color in the dipole stem, whereas it did not give any color in the water. And Clitoria, it gave color in both water as well as in methanol. Here all the cotyledonous cells were dark brown, pedicel and alveolar was light blue, and endosperm was pale blue. So these are my sections. Here the effect of ATM Sepa dye on various plant section. Here the dipole sleeve was well stained. Here you can see the all cotyledonous cells, they were pink, dark pinkish in color. Then effect of Areca Catechol dye, A, B, C and D strands, it is water extracted samples, and these are methanol extracted samples. Here Areca Catechol gave good color in water. It gave also color in methanol, but in water the color was good. This is the epidermis which was stained dark brown. This is the secondary xylem and the pith. The dipole sleeve was also well stained. Then effect of Cassia fistula dye on plant samples. Here also the water samples gave better results than that of the methanol. Dipole stem was well stained. Here you can see the cuticle layer which is dark brown. This is the phloem, xylem and the pith. And Clitoria tenacia gave good results in water as well as in methanol. Here dipole seed was well stained, that is all cotyledonous cells were dark blue in color, and monopod seed was also well stained. Here this is the pericarp, alveolar layer, and this part is the endosperm. Curcuma longa gave color in both water as well as in methanol extract. The dipole stem was well stained and monopod seed. Then Garcinia indica gave good color in water extract. That is dipole stem and the monopod stem was well stained here. Lawsonia and it gave color in water extracts, and it did not give color in, when dissolved in methanol. Whereas Pixa Orellano gave color only in the methanol, that is yellow color was also. Tectona grandis, it gave color in the water. It gave good color in the water than that in methanol. Then Tagetes it gave color in both water and as well as in methanol. Light yellow color was observed. Nicantis arboristiis also gave color in both water and methanol. Here you can see the yellowish color. Then Pubica Verenkar, it did not give good color in both the extracts, water and methanol. Then spectral analysis, some dyes extract they have poor color imparting features. feature, and some some dyes they have high color imparting feature. So low absorbance indicate that poor color imparting feature, and high absorbance means high color imparting feature. So when there is one peak in the spectra, it indicates that one chromophore is present in that, and if there is more than 2 peaks, more than 1 peak, then what? Then we said that more than one chromophore imparting feature is present in the particular dye. So areca category and the Arium cepa, these have 2 peaks. This is 1 peak. Here the solvent which are used is water. Here methanol was used. Then Pixa, Cassian, Clitoria, they have 3 peaks. Curcuma longa, it shows absorbance more than 2. Also the Lawsonia inversus gave highest absorbance, that is it was more than 2. That means it has good staining property. And in Tentis arboretum we give the absorbance more than 1. And Punica venetum, it gave the lowest absorbance out of all the dyes which I have expected. Then Tentis it has showed.
What is the y-axis? Starting point, I can't see it. Starting point, where it starts? What is the wavelength starting? 400, no? Which one? Thank you.
So Tentis selecta, so among all the dyes which are expected, Tentis selecta showed the highest absorbance, and that's why staining property was also good. Then Tentis selecta, Tectona, Lawsonia and Curcuma, these 4 dyes they have the absorbance more than 2. And Pixa and Tentis, it has the absorbance more than 1. And Arium, Garcinia, rest of the dyes they have the absorbance between 0.1 to 1. And Punica, it has the lowest absorbance, that's why it did not stain very well. And synthetic dye spectra also have taken of actinium, bromophenol blue, toluidine blue and safraline. So it was observed that absorbance of actinium orange will correlate with the areca catechu. That indicated that there is a presence of some phenolic and carotenoid compounds in there. Coming to the conclusions, out of 12 natural dyes, 4 natural dyes were used as potential biological stains because of their high absorbance. And 1 peak in the spectra indicated only 1 color imparting chromophore. And these dyes, 4 natural dyes, can be used as a potential dye for both biological as well as textural staining. However, specific chemical compounds which is responsible for staining of this biological tissue may be further identified.